Okay, so when we're doing this unit, guess what's going to come into play? Factoring. This whole unit is going to deal with factoring. Okay, so you have to be proficient at factoring. I told you guys that on that unit. Like, you had to have about 80 or more % on that one test to show me you can do all this stuff. Okay, so let's just recap. So we have simple trinomials. So to do a simple trinomial, xx, that's making the x squared. What are the rules? Always needs to multiply and add. So you have to think of something times something to make 24. 6 times 4. There's one of them, and that would be a plus. One's a minus. Multiplies to negative 24, adds to 2. Okay, complex trinomials. So my flow number is 12. Can you think of multiples of 12 that would add to 13? I'm not going to write the whole list of 12. I'm just going to think about which one makes 13. Multiplies to 12. They're both positive because I need plus 12 and I need a plus 13. Okay, I'm going to write some options here. This is my FOIL process broken down. So how could you FOIL to this 1x times 3x? How could you get a FOIL to make that 1, 4 or 2, 2? So can you pick some partnerships that make a 1 and a 12? You got to make a 1 and a 12. So x times 3x remember, I kind of always draw my rainbows. Outside connects to a 1, inside's connecting to a 12. Okay, next one, the difference is squares. So x times x to make x squared. And you need a plus minus. And you're trying to multiply to negative 64. And there's nothing in the middle of this trinomial. It's not a trinomial because there's nothing in the middle. So technically, you think it has to multiply to negative 64 and add to 0. Okay, GCF, recapper. So when I look at these terms, what could they both be divided by? 2m bracket. So 2m times m. And then you would have to do 2m times 4. Okay, this last style, this one's new. So we haven't done this one before. Okay, so this is not what we did last time. All right, here's what I don't like. I hate dealing with negative variables. It's not fun to factor. Okay, so what I'm going to do is I'm going to GCF a negative 1 out of this. Okay, then do you always see in my brackets, I always like to write my variable first. Okay, so once I take the negative 1 out, what is my variable now? Positive x. And what's the number now? Positive 6, because I took the negative out of it. Okay, so this is the same thing. Negative is in front of the variable, so I'm going to negative out it. So it's just a GCF. So if I take the negative out of this, it's x. And what's the number to write now? Subtract 9, negative 9. Okay, restrictions. So there's one thing about fractions that can never happen. What do we know? When we have a fraction, we can never do something. Divide by 0. Okay, so on these questions, when I say what's the restriction, I'm not looking at anything except the bottom. That's all I'm looking at. Okay, this symbol says x cannot be, cannot equal. What value can x not be? So in other words, what makes it 0? If x was 3, because then the bottom would say 3 minus 3, 0. What can x not be here? 0. If x was 0, the bottom 0. X cannot be, okay? What did you guys do when you had factors like this? What did we always say? Remember with complex trinomials? What did I always say as a trick? Opposite divide, right? Opposite divide. It's the same technique, right? If you were in an equation, you would have moved the 1 divided by 2. This is the same idea. Can you give me, it's a fraction, it's a complex, factored. So x cannot be opposite divide. Okay, really? Do we understand what I'm doing? I'm just doing this as an algebra, right? Move the 4, divide the 5. Okay, this, I'm going to factor. That's what I'm going to do. You can really kind of think, again, like, this is what I'm trying to do. I'm trying to do that. And we've done this work with factoring. So x multiplies to 40. 8 times 5. So x cannot equal 8 or negative 5. Okay, this one, you could do it in 2 ways. You could do opposite divide, or you could GCF something. Opposite divide. So I had 2 methods I could have picked there. I could have done the opposite divide, or I could have GCF'd an 8 out. Okay, so this is going to lead us into how to reduce rationals. Okay, so everything is always just about factoring. Okay, so go ahead. I need you to factor the top, and I'm hoping now you're identifying styles is quicker. Top, you should say, hey, that's a simple. What's the bottom? Difference of squares. So give me a factor, factor, factors. Okay, question for you. Did you pick 6 times 1 or 2 times 3? You should have picked 2 times 3. Multiplies to plus 6, adds to plus 5. Okay? Now, this is a multiplier and this is a divider that are the same. So what can you do when something's the same? Cancel them. And that's your final answer. Okay, I want to get this straight. Is anybody thinking, well, why can't she cancel x's? I'm not sure if that's going through your brain. Okay, you can't. So in math, you can only cancel multipliers and dividers. So when I had these factors set up, it was like this unit times this unit, divide by this unit times this unit. Okay? I don't have that situation anymore. Okay? I'm going to give you an example. Okay, so here's this big idea because people go wrong. This is where people go wrong in this unit. Okay, so this is 12 over 15, okay? I can do this cancel because it's timesing and dividing. So that's 4/5. Is that accurate? Is that the same thing? Okay? This would make 7/8. Okay? If somebody went wrong and they tried to cancel this, it would be 4/5. Is that doing the same math? No. Okay, so that's how you have to get it straight in your head. You can only cancel when things are connected, multiplying. Okay? If something is an adder, so this is being added, I can't cancel now. Okay? Still fighting my grade 12s with that idea. They keep trying to cancel stuff like that, and you can't. Okay, here we go. I recognize the top, so recognizing complex. So FLA is 8. I'm going to be trying to find a 1 and an 8 to make a 9. So here's how I can make 2x squared. Here's how I can make 4. What's the combo to make a 1/8? 1/8. Okay, bottom. What do you want to do with the bottom? It's something. We got to do some work to it. Negative out. That's that new style. Okay, why? Because I don't like negative variables. Yucky. Okay, negative out. Okay, what does our factor become? What's our letter now? Not negative x, positive x. Not negative 4, positive 4. Okay, now look at what happens. x plus 4 multiplied on the top, divide by an x plus 4. Two x plus 1, and then negative 1 on the bottom. And then you can do this work. You can divide this by negative 1 and divide this by negative 1 as well. You have to do it to all, right? Does everybody know that this has to apply to everything, like a bracket kind of idea? Okay, one more, and we're done. Okay, every time you look, you should say what style. That's your first brain thought, the styles you see. Okay, recognizing I got GCFs on both. Okay, so when I look at the top of these two terms, what could I divide them by? 2m bracket 2m times m, 2m times 1. Okay, on this one, everything has a what in it? An m. Okay, we're going to go further on the bottom here though. Can I break this one down more? So, okay, so remember we have to keep that m in the front still. M multiplies to 2 and adds to 3. So 2 times 1. Okay, so right now we're fully factored. Okay, so now I'm going to look for cancels. Is there any multipliers and dividers that can go? M plus 1 divided by m plus 1. Any other multipliers? There's something else. What else? I can cancel 2 times m divided by an m. I can cancel the m's. Okay, why can't I cancel these 2's? Because this 2 is not a multiplier. It is an adder. You can't cancel something like that. Okay? I'm hoping you can clearly see the difference between when I say something is a multiplier or like an adder. Okay?